Algebra OST Spring 2025, release test item number 20. It says a equation of a function y equals k of n defines a geometric sequence where the first term k of 1, or where the first term is k of 1. A table of values for k is shown. What is the 8th term in the sequence? So when you think of geometric sequence is related to exponentials and multiplication. So as these x's are increasing, right, something is happening where these are being multiplied by something, right? So there's a couple ways to do this. The first way I'll explain is hopefully just by you looking at it, right? So if we take a look at these numbers, right? So these are just sixes with different place values of 10, right? So if we start with 0.6, right? Notice there's a jump between the 2 to the 4, right? If we times 0.6 by 10, we get 6. I think that that is the third term in the sequence. I think the second term is 0.6. I think the third term, which they're not including, is just regular 6. Because now, if you take regular 6 and times it by 10, now you get 60. And I think that is the fourth term, right there. So I think that all they're doing is every time they're multiplying by 10. So what we're going to do here is we're going to take the 7th term, because they want the 8th term now, right? We're going to take the 7th term of 60,000 and just simply times it by 10. And you're going to get the 8th term, which is going to be 600,000. When you type it in here, I don't think that the comma matters. They actually didn't let me type the comma in. I was going to say you could also graph this, right? But I think it's going to become too much. Let's just do it real fast. Let's see what happens. So if I grab the table, so if I do 2, 0.6, if I do 4, 60, and if I do 7, 60,000, right? So there's what I have here. Okay, now there is something fun. Let me erase the writing so we can see. So I put that table in. Now, if you can remember that geometric sequence is exponential, there is this fun little regression thing. See where it says linear? You could change it to exponential, right? And it'll give you, see, it gives you an equation, right? So now you could plug that value of x in, or I wonder if it would, it doesn't predict it for you, dang it. I wish it would predict it for you, but you could plug x in there and see what you get. So if I plug in, let's see. So if I do 0.006 times 10 to the 8th, if I plug that in to my calculator, or I wonder if, let me see something first. Let me see if I press the, nope, done. Yeah, I thought maybe it would let me do a table of values for here, but it didn't. Okay, well, what you could do is this. You could type that in down here, right? So y equals 0.006 times 10 raised to the x. You can use the AB button, which is right here. Okay, and now I could use that right here and give me that table of values and change this to an 8. When I change it to an 8, there's also 600,000, right? So different ways to do this problem. But again, in the end, all you're doing is multiplying by powers of 10.